Thank you, Steve. So this is an impressive list of use cases, right? From just one city with only 100,000 inhabitants. So I'm impressed always by these presentations from Helmond. My name is Menno Malta. I'm the CEO of Monotch, and I will share a bit of background about how we help cities such as Helmond to do this variety of use cases around intersections. So let's start with briefly introducing our company. Monotch makes traffic talk. And what that means is that we connect the roadside to the road user in real time. So we add a sort of a real-time layer to the transport ecosystem so that all the actors in the ecosystem can have a conversation with each other in real time and change their behavior in real time, make the entire ecosystem much more smart and dynamic, because we think that's what's needed for the next era of traffic management. So simplified how this looks, it means that we have a platform which is called TLEX, Traffic Live Exchange, and this platform connects directly to VMSs, traffic light controllers, roadside tuners, sensors from many different suppliers and vendors. And it also brings this data to traffic management and to information systems. We call them CITS applications. So that would be companies such as TomTom, HERE, INREX, and also fleets, dedicated fleets like ambulances, public transport, etc., etc. So imagine that all these actors are sharing status and information with each other. What can you do with that as a city, as an authority? That is the journey that we're on. Now, over to Helmond. What does it mean for Helmond and their traffic lights? So here we see a dashboard that they haven't seen yet actually, but they will see it in a few weeks when our new version is released. But here you see a status dashboard showing all the connected traffic lights in Helmond, and you see straight away that we have some KPIs there. So it's not just about connecting them, it's also about managing this data quality. And I will go fast through the presentation because I have probably more slides than time, so apologies for that. So how does the architecture behind this ecosystem look like? Well, we do have, of course, the road users, and they have their interfaces. And it can be anything. It can be an onboard unit in a bus or an ambulance. It can also be a consumer app that has this data and shares data. And then these days, it's also directly the dashboard for from some OEMs already that bring this data directly to the road user. On the left side of the ecosystem, we have all this roadside infrastructure that I just mentioned. It's important that this is from all the vendors, from all the suppliers, and that this is open and interoperable. Otherwise, we cannot get to this vision of this connected ecosystem. And then we have public fleets, and whether they are in the domain of the authorities or the domain of the market, you can discuss. But why do we have this blue and green bar on top of it? It's because sort of who funds what. And the left side of this ecosystem is funded usually by the authorities, cities, highway authorities. The right side is for the market, meaning that these service providers have to build a business model around this data. And they succeed in that. We've seen it in the Netherlands. And then we have the CITS hub, sort of generalized, which is in this case the TLEX platform. And it has 6 key functions. It's data exchange, and this is a lot of data, and it's super fast. It's aggregation of data, and it's federation. So federating data from different authorities so that these car OEMs and navigation companies can just connect to a network of data exchanges instead of having to find out where this data is. And then there's quality control, because that's also learning. OEMs will never join this ecosystem if data is not consistent, harmonized, and really of reliable quality. Equally important, by the way, is governance. Who is allowed to bring data into this ecosystem, on what conditions? Who is allowed to consume data? And then the service providers, they basically take this data and make services out of it. They sell it to OEMs, to the other parties in the ecosystem. So this is the architecture, and all this interfacing is done with public standards. So between these actors, there's no proprietary interfacing. A brief word on latency, because all of this is done with cellular networks. And initially, when we started this as part of the Talking Traffic program, started in 2016, we were given a budget of 1500 milliseconds. This was sort of seen as possible and also acceptable for these use cases. Now, we've done a lot of research in the meantime, And we found that we are consistently around 150 milliseconds end to end. This means that a change of light from traffic lights will be in car around 150 milliseconds. Now, as a human, you don't see it. You blink your eye and it's there. So it's super low latency, meaning that we can facilitate many of these use cases that Luc was describing. So latency is fixed. And here we actually see something from a Helmond traffic light 2 weeks ago when I created this slide in preparation for today. So you see a lot of data. On the left top side, you see signal phase and timing messages, basically information from the traffic light. And what you see here in general per hour, this is above 10,000 messages that one intersection is sending out to our platform. We bring it to all the service providers. Then in the mid graph, you will see the CAN messages, basically the status messages from road users. Around 15,000 in the peak hours. So all of this is information for the algorithm that controls the intersection, making it super smart and dynamic, combined with the loops information. And then at the bottom, we have a graph showing priority requests from ambulances, fire trucks, in the future also public transport. So this is real, this is at scale, and it's very dynamic. Brief word on quality. Quality is there on many levels if you want to be successful. So it's about connection quality. This is low latency data. So can you imagine that the clock of a TLC is 1 second off? We cannot use the data anymore. So we monitor continuously clock settings, synchronization, things like that. If there's a problem with a connected object, we will either alert the owner or even drop the connection, because we don't want to sort of have garbage in, garbage out, because that will scare away the OEMs, TomToms, etc., those parties of the world. And they bring value to this ecosystem for the authorities. So there are many layers here, and for the sake of time, let me continue and zoom out a bit, because this is not just live in the city of Helmond. Luc already briefly mentioned this. This is live at a large scale in the entire country in the Netherlands. Around 25% of all the traffic lights are now connected, made smart, sharing all these messages. And we have around 25% of all the cars on the road also connected. And when I say we, it's the ecosystem. It's through these apps and onboard units. It's not our work. We are the layer in between that makes it possible in that way. So live at large scale, meaning that we exchange around 1.3, 1.5 billion messages every day in the Netherlands. And this is growing month over month. We know we will be at 2 billion by the end of this year. So it's an ecosystem. So you will see and recognize these logos. I think this is also growing. As I say, car OEMs are now joining. So this is a growing ecosystem, which will also grow the number of connected road users and grow the impact of the ecosystem and the deployments. And this is the dashboard for the Netherlands. So all the cities have their own dashboard, but the supervising authorities can sort of monitor the quality of what's going on. One more element, especially I think relevant for the UK. In the Netherlands, we have one central environment, and which is procured by the Dutch Ministry of Transport. But we also facilitate federation, meaning that we have data hubs from different regions and authorities that can work together in a network. For this, we use the C-Roads II interface, again, a public standard. And this allows service providers to connect to a network of hubs from road authorities so that they know exactly what data is available, what the quality is, and where they can find it. Again, this is a key element for further growth of the ecosystem. This brings me to the end of the presentation. In the end, we started Monotch and our platform to take care of 4 key issues that we see in CITS. It's a focus on technology, it's a silo approach that we still see, and being stuck in pilots. So I see a repeated sort of redoing pilots in different countries around the world. And as a result, there's not a lot of audience in these pilots. We wanted to break that cycle. That's why we created this platform, build it based around interoperability and open standards. And our end goal, of course, to have impact with it, but on the short term, what it does for authorities and cities is that it frees them of the technical stuff and allows them to focus on use cases, such as Luc described in his presentation. We're also active in the UK, more and more, I would say. So here we have some contacts from our organization, and we also have a table here, so don't hesitate to come to us if you have any questions. Thank you.